Following on from the previous video, we were trying to integrate the inverse tan of x. So now let's proceed. So to integrate the inverse tan of x, let's start with this. So using this formula for integration by parts, visualize as this. You've got one block, and then you've got another block here, which is the number 1. So now let u equals this, and let v prime equals 1. So let u equals the inverse tan of x, and then let v prime be this number 1. Okay, so if u equals the inverse tan of x, then du then u prime equals this thing here, because when you differentiate this, it will give you this. Now if v prime equals 1, then normal v will be x. So now just follow our normal routine. So get u times v. So u is here times v, which is here. So that will be x inverse tan of x. So that's this bit done. Now take away the integral of u prime times v. So u prime times v, which is this x over x squared plus 1 dx. Okay, this dx here is this dx here. So following our formula, it would take us from here to here. Hang on. Oh, sorry, hang on. So following our formula, following this formula, it will then take us to here. Now remember, when you're integrating something, try to keep an eye out on something where try and keep an eye out for this, because if you look at this here, this is the exact derivative of this thing here. So when that's the case, then you know if you integrate this, it will be the natural log of u. Because if I were to ask you to differentiate the natural log of, let's say, a bubble here, then it would be, if you differentiate it, it will give you 1 over the bubble, and then you've got to use a chain rule, times the derivative of the bubble itself. And then here you've got a fraction times this derivative bubble here, so it gets multiplied to the top. So it will give you bubble prime over bubble. So when you're integrating, keep an eye out on something being the exact derivative of the bottom thing. So when that's a case, then when you integrate it, it will be in the form of natural log of something. So if you look at this, hang on, let me just tidy this up. Bear with me. Let me just tidy this up. So we are currently, hang on, we are currently here at the moment. So to integrate this, keep an eye out on something being in the form of derivative, and then keep an eye out on something being the derivative of the bottom thing. Well, when this is the exact derivative of this, then when you come to integrate it, it will be in the form of natural log of something. Okay, so if you look at this now, hang on. If you look at this now, this here, when you differentiate it, it will give you 2x, which is near this thing here. So let's rewrite this. Let's rewrite this as 2x times a half. So earlier we were here. Hang on. Earlier, bear with me. Earlier we were here at the moment. Well, earlier we were here. Okay, so if you look at this here, rewrite the x, rewrite the x as this, 2x, and then times a half, because a half times 2x is x. So you can write x as a half, and then times 2x. So look at this. This now is the exact derivative of this thing here, and this here is a constant. So let's take it out. Okay, so that will then give you well, so hang on, bear with me, hang on. So we were here at the moment. So we were here, and then rewrite this x here. Rewrite this x as this thing here. So here you've got a half, and here you've got this thing here. So the reason why we're writing it like this is because if you look at this here, this thing here is now the exact derivative of this thing here. This is a constant, so let's take the half out. So that will then give us this. That will then give us this. Now, if you look at this here, this is the exact derivative of this. So when we come to integrate it, it would be this, the natural log of this thing at the bottom here. Okay. So when you're integrating something, keep an eye out on something being the exact derivative of another thing. So in this case here, keep an eye out for this, and then you know that when you integrate this, it would be something in the form of this. Well, anyway, from here, if you integrate this, it will then give you this, and this is our final answer. This here is our final answer. If you want to integrate the inverse tan of x, then it will be x times the inverse tan of x, and then take away this thing here, plus a constant. Okay.